Okay, so today what we're going to talk about, well, before we start talking about it, I'm going to have you guys get into groups of 3 or 4 people. I'm going to assign you, I'm going to give you 1, 2, or 3, and then you get with all your 1s, all your 2s. That way it randomizes things. And then what I want you guys to do is I want you to discuss what makes us human. What is it that distinguishes us from other animals? And I want you guys to come up with a few points and then write them down. Be prepared to present them when I call on your group, because I will be calling on all of you to kind of get a good, well-rounded discussion of what we all think makes us human. We're going to spend about 10 minutes on this assignment. 5 minutes of this will be spent talking in group, and then 5 minutes of this will also be spent engaging together as a class. And then when we're done with that, we'll move on with the lecture. 10 minutes time lapse. So all of those were very good points. Let's see how many of you actually came in line with the lecture. And today what we're going to do is we're going to talk about the 6 steps to humanness. These are going to be 6 things that distinguish us from animals and make us different, make us who we are. Now bear in mind that although some of these traits are exhibited in animals as well, the fact that we as a species demonstrate the ability to do all of these things is what makes us human. So first, we're going to talk about bipedalism. Bipedalism evolved in hominids 6 million years ago. And the first thing I want to talk about that separates us from, in this case, primates, the chimpanzees, is we're going to start from the very top. The skull attaches at the foramen magnum, which is, in our case, located directly at the bottom of the skull, whereas with primates, it's located in the back of the skull. And if you guys have a look here, you can see clearly how it lines up outwards for the chimps, and where for us, wait, that's the wrong one. No, that's correct, I'm sorry guys. Right here for us, it comes straight down at the bottom, right here. And for gorillas and other primates, it comes out this way, and then it starts going towards the back. And what you also notice with this is our head is carried straight on top of the spine, whereas for primates, you notice that their head is projected forward on their body. And because they're walking on 4 limbs, they're walking with their head sticking out first. Whereas with us, we're walking straight up and down. Nothing's really projecting forward or backward except for our arms when we're swinging them. So because the way the foramen magnum is located on our skulls, what you also notice is the way the spine is shaped. Now for primates, the spine is slightly curved, whereas with us, we have an almost deliberate S-shaped spine. This kind of helps us stay straight and walk forward. It helps us maintain our stability. Other things that we should notice is that our arms are going to be shorter than our legs, whereas with primates, their arms will be longer than their legs, and they're also used for walking. I know sometimes you've seen footage of primates, they can stand up and walk on 2 legs if they need to, but they don't really do that for a prolonged period of time. It's more efficient for them and a lot faster for them to move when they're walking on all 4 limbs. Another anatomical characteristic worth considering is our pelvis. We have a smaller bowl-shaped pelvis, where primates have a long and narrow pelvis. And then finally at the bottom right here, we have femurs that are angled in, kind of straight up and down, whereas with primates, they're kind of like almost bow-legged, because they're kind of doing this, so their legs bow out a little bit. Another thing to consider with bipedalism is right here where you see the way a primate walks compared to us. This helps us maintain, homeostasis a little bit better, because with just sun hitting us on the head, there's less solar radiation heating our bodies up compared to primates, where if you're walking on 4 limbs, the sun's going to hit you all across your back and your head, so there's going to be more heat directly impacting your body. And then also because we're standing vertically as we move, winds, as they come in, they cool our body much more efficiently than they would a primate. So you can kind of notice how our body temperatures work when it comes to homeostasis, when it comes to solar radiation and wind as well. Now there are some things that are not highlighted in this graph right here that I do want us to consider that will be important in the future. One of them is going to be the way their feet are shaped, and also the way hands are shaped. If you look here, this is going to be a human foot and this is going to be a primate foot. This almost looks like a hand. Also, you notice the toes curve and their thumb, or their big toe in this case, looks just like a hand, like it's doing this. Whereas if you look at a human foot, what helps us maintain our balance is the fact that we have a non-opposable big toe, helps us to maintain our stability. Also, if you notice, from here to here, our toes are going to be a lot shorter than those of primates. Primates need their toes to be longer on their feet because they use them to grab onto branches better. Also, what we have that helps us with stability is going to be the arcs right here and right here. The arc on top is going to be the medial arc, and then the arc on the bottom is the lateral arc. Now, compared to primates who have a completely curved foot, the arcs on our foot help us maintain stability as we walk, and they help support our weight as we walk and move and run. If we were to have completely flat feet, it'd be very difficult for us to get around. It'd be very painful for us to walk long distances, I'm sorry. So those arcs right there do play a big role in how we get around. Another thing to consider is our hands, like I had mentioned. Now, if you look right here, between an orangutan, a gorilla, and a chimp, their hands have considerably longer fingers, and their thumb is short compared to this one right here. So we have a longer thumb, and then also our fingers are going to be shorter and flatter, and they're not going to curve just the same way as primates. Primates need those curved fingers in order to, again, grasp onto branches, swing in motion, fly through the trees. So because they have a shorter thumb than we do, they're not really able to do this. This is something we can do, which is, again, going to be very important for our one of the other steps in what makes us a human. And you can see right here, these are the different kinds of pinches and grips that we can do with our hands because of the way it's structured. These are the different ways we can hold items to open them. Primates can't really do things like this because their thumb isn't as long as ours. Ours is longer comparatively to theirs. So this kind of leads into one of my other steps of humanness. So I do want you to keep this in mind and remember it because it will be important. So before we move on, I know this is a lot that we've talked about for just one step. In your same groups, I want you to come up with a costs and benefits analysis for bipedalism. What are some of the advantages that we have? What are some of the disadvantages we have as bipeds? Once again, write down your main points. Be prepared to present them as a group when I call on you because this is going to create a discussion and I want to see how well you can apply the things you've just learned into an analysis of what's good and what's bad about what we do. We're going to take about 10 minutes, 5 minutes to talk about it amongst yourselves, and then 5 minutes to come back together and engage as a group. The second step that's important in our humanness, so to speak, involves non-honing chewing. Compared to other primates, we have smaller canines, which are going to be your vampire teeth, if you will. And then also other anatomical characteristics include the fact that our canines not only are smaller, but they do not project outward. The muscles that we use to chew, right here, these masticatory muscles, for us, they're going to be having a more vertical position, which is going to allow us to eat like this, grinding down on the food, chewing down on it. Whereas with primates, their muscles are a little bit more horizontally oriented, and these canines are important because when they chew down on food, they do more of a slicing motion like this. So as our muscles have changed in our heads, it's also lined up with the way our teeth are formed as well. So we've gone from a slicing motion to more of a grinding motion, pressing down, relying on our molars more. We also, as you can see right here, because we no longer have projecting canine, we no longer have a diastomer right here, a space between our teeth. Anytime you are more likely to notice a diastomer in our teeth is when we have it right in the middle between our front two teeth, that tooth gap. So it's kind of funny, sorry if you have one. But it's going to be the only type of diastomer that you can immediately see in someone, and not one that's kind of hidden behind them because they don't have projecting teeth. Another thing that's worth considering as well is because of the foods we eat now, we do have a thicker enamel. So the enamel on our teeth is going to be better suited to eat more foods that are tougher to chew on. Other anatomical characteristics include wearing on the tips of our canines and our third premolars. The cusps on our lower third premolar are of the same size. And thicker enamel, which we already talked about. So while humans have non-honing chewing, primates have the honing complex. And what that means is most of their work on chewing food is done with their canines at the front of their mouth, where they can slice it up. And now we're going to watch a clip that kind of highlights the emphasis of both of these two steps that we just talked about.
What could walking on two legs have to do with small canine teeth in these earliest hominids? One possible explanation comes from studies of primate behavior and anatomy.
In Ardipithecus, the canines have dramatically reduced, and this tells you that somehow there's been a major change in social behavior.
In all other primates, males use their canine teeth as weapons to threaten and fight with each other. They fight over females who show visible signs that they're ovulating. Male Ardipithecus canines are greatly reduced, like ours.
If male canines are reducing, it means that females are choosing males with smaller canines. What could a male be doing that would make a female want that to have the offspring of that male rather than those of a more competitive, more aggressive male?
One possible answer is that by pairing with males who were dependable sources of food, females had more time and energy to devote to their youngsters and to have more of those offspring during their lifetimes. This is what winning the evolutionary sweepstakes is all about: reproduction and survival. The formation of what scientists call a pair bond between males and females would have been based on the exchange of food and sex. With this kind of system, males could have foraged separately from females and their infants. The all-important reproductive advantage would have gone to those males who collected and carried high-value foods to their mates and their dependent young, whom they likely fathered. Natural selection would have favored those who could walk farther on two legs, carrying food more effectively. Males with smaller canines. Pair bonds reinforced by regular sex, carrying and sharing of food. Could these be the keys to the evolution of bipedality?
Okay, so now we're going to move on to the next aspect of humanness, and that is going to be complex material culture and tool use, which evolved about 2.5 million years ago. Humans are heavily dependent on culture for day-to-day living as a species and for survival. This also includes learned behavior transmitted from person to person. Now, it is true that we have seen evidence of other apes exhibiting some forms of cultural behavior, but the tools of our closest living relatives, the chimps, they do not approach the complexity and diversity of the tools that we make, the diversity of modern and ancestral human tools. A common example is when you see a chimp who's trying to eat ants. They'll get a stick, they'll go to an anthill, and they'll dip the stick inside, and then once they pull it back out covered with ants, they'll start eating them off the stick. That's one of the prime examples of how apes use tools in their own lives. Now, evidence for material culture in the form of primitive stone tools dates back to about 2.5 million years. And one of the best examples of this is right here, the Oldowan tools. The Oldowan tools were found in Olduvai Gorge in Tanzania, and they date to approximately 2.6 to 1.7 million years. And then another example that's much more recent, and you can start to notice the difference in the levels of complexity between these tools and these tools right here. These are the Mousterian tools. These tools were found throughout Europe, and they were dating to 300,000 to 3,000 years before present. Now, it's not just tool complexity that is important, but for now we're just going to focus on that. So imagine finding these types of tools where we started to where we are today. And this is just a rough example of it. I mean, look at the different sizes of wrenches, the screwdrivers, flatheads, Phillips, and even power tools. They've gotten completely complex. They've gotten more intricate. And what do we use these for? We use these for our survival in order to build homes, to build things, to build furniture, to build shelter. So we do rely on these tools for our survival. We rely on tools to fix the cars we use to go to work and to go to school and to go buy food. Because some people don't live in a dense city where they can just walk everywhere. They can just live out in the rural countryside. Maybe they don't like hunting, so they'll just go to the grocery store and buy it. Another example of complex material culture, which if we properly define it, it refers to the relationship we have between artifacts and social relations. And to be quite honest, material culture can be almost anything. Anything we make, anything we build. Intricate as clothing, in fashion, books. These are books. I know it looks kind of wonky, but it's an architectural display that is made entirely of books. Architecture, this is a medieval church in Siena. Crafting, the things that we make for storage, or the things we make for fun, or the things we make to make people happy, that's a form of material culture. And then technology now, tablets, cell phones, computers, laptops. I'm pretty sure we could survive without them, but in all honesty, I don't think we could survive without them just because we rely on them so much. And this is just one way to kind of glance at the variety of what we can consider material culture. Different people use different things for different needs. And again, material culture can be almost anything. The next step to humanness is speech, and speech evolved around 2.5 million years ago. We are the only animal, the only species that communicates by talking. Although other animals are known to use noises, vocalizations, and calls to communicate basic ideas, only humans can speak, and through speech, include complex thoughts and ideas and express those. And this has kind of been made possible because of this right here, this kind of horseshoe-shaped bone. This is the hyoid bone. Now, it changed in a way that what it does is it helps support the tongue, and it elevates the larynx or your voice box when you talk or when you're trying to swallow food. And what's very significant about this is the only bone in the body that is free-floating and not attached to another bone. It's supported by ligaments that are also attached to the skull, but it's technically not tied to any other bone or connected to it. So that's one of the unique things about it. And the shape that it has is what allows us to speak. And building on this notion on the complexity of speech, we can also move to include nonverbal forms of communication, such as body language. I'm really excited to be here.